Hello, this is Akram and today we are going to talk about binary coded decimals, means how we can convert binary numbers into decimal numbers. First thing we learned about digital electronics was the number system and how we can convert one number system into another, like binary into decimal or hexadecimal and vice versa. So today I am going to show you how you can theoretically convert binary into decimal, or how we can practically build a circuit to convert binary numbers into decimal, and how we can show it to a 7 segment. Okay, so first of all we need the components, and for building a circuit we need components like first of all we will need a 4-bit input data, and I'm going to use a dual inline package switches 4-bit, and then we will use a 7441 IC which will actually convert the binary into decimal for a 7 segment, and at last we will need a 7 segment display. I'm going to use common anode 7 segment display, and you can also use a common cathode, and we will need 4 10k resistors and to pull down these switches. So now I'm going to show you how you can actually convert binary into decimal using 8421 code. So first of all, let us suppose that we have binary here and decimal. So I'm going to convert binary into decimal using 8421. So first of all, see, let us suppose that I want to write binary and a decimal here, and I have decimal like 1. Okay, so for 1 we will write the binary like for 1 here we will write 1 and then all zeros. Okay, then binary will be 1. So let me just give you another example, it will be more clear. So let us suppose that if we want 3 in decimal. Okay, so for 3 we will write 1 here, and for 2 means 2 plus 1 will be equal to 3, and then it will be 8 and 4 will be 0 0. Okay, so for binary it will be 0 0 1 1, and here it will be like this. Okay, and similarly let us suppose that if we want to write something like 6. Okay, so for 6 we can write 6 like 4 plus 2 will be equal to 6. Okay, so 0 1 1 0. So basically here we need to write 1, and we can add these 8421 from any number from 8421, and we will get the equivalent result in decimal. So in binary 6 will be 0 1 1 0. These are actually the binary numbers here, and I am writing the same in here as a binary also, and this one these are the decimal numbers. And similarly if we want 8, okay, so we can write 8 like 8421, so we can write is 1 0 0 0, and similarly. So these 4 switches, or you can say that these are the 4 bits, and I'm going to connect these 4 bits, or I'm going to give these 4 bits of data using the switches. Okay, the DIP switches, and then this data will be fed into the 7441 IC, and then it will be given to the 7 segment display. So this one is the board I just built, and here we have a 4-bit data I'm giving through the switches, and this one is the voltage regulator actually, and this one is the 7441 IC, and here is a 7 segment display. I have connected 4 1.5 kilo ohm of resistors to pull down these switches, and I have also connected 150 ohm of resistors for the current limiting to the 7 segment display. Okay, so now I am just going to show you how we can send the data and how we can show the data to the 7 segment display. So first of all, it's 0 means all the switches are closed here. Okay, so if I am going to push just 1 bit here, you can see here this 1 is printing. Okay, and now let us suppose that if I want to show 3, okay, then 1 and this one has to be on, so that this will be 2 and 1, so 2 plus 1 will be 3. Okay, and similarly let us suppose that if we want 7, then 4 plus 2 6 plus 1 equals to 7 here, and if we want just 8 here, then the last bit of the switch will give us the 8, and let us suppose that if we want 9, so 8 plus 1 equals to 9. And similarly in this way you can actually learn and build more stuff for the display using the 4-bit of data, and you can also code it with any microcontroller like Arduino or any other microcontroller which you find useful. Okay, thank you.